In this video, we will be learning about the rational root theorem. But first, let us get some objectives. In this video, you will understand what the rational root theorem is, its functions, importance, why it's called a theorem, be able to answer different equations with the rational root theorem, and to check the answers using other possible solutions. Today, we will be learning all about the rational root theorem. But first, let's learn some learning objectives. In this video, you will understand what the rational root theorem is, its function, importance, why it's called a theorem, and be able to answer the different equations using the rational root theorem, and lastly, to check the answers using other possible solutions. If L is a factor of a constant term, and F is a factor of a leading coefficient, then the rational number L over F is a root of a polynomial equation. But what exactly is LF? We will get to that shortly. The zero of a polynomial is an x value that gives a value of 0 when substituted into the polynomial. If the 0 is a real number, then it will also be the x-intercept of a polynomial function when graphed. Finding these zeros may be time-consuming and guesses are most definitely not the best way to tackle this situation, as there are so many possibilities. So this is where the rational root theorem comes in. The rational root theorem helps obtain a list of guesses when trying to find the roots of a polynomial. With a polynomial that makes use of integer coefficients, positive or negative whole number, the possible roots can be found by first looking at the factors of the constant last term over the factors of the leading coefficient, which gives you the list of fractions or whole numbers where the denominator is 1. Remember L over F, last being the constant or last term and first being the leading coefficient, which is the first term, or simply last over first. This list of fractions gives you the potential roots that you can then test. To be clear, the rational root theorem does not give you the roots of the polynomial equation, only the possible roots which you can then use to test. Hence, it is called the rational root theorem. This means that only a few from the list are actually zeros, solutions, or roots of the equation. The number of roots can be determined by the degree of the polynomial. For example, with the equation x to the power of 5 plus 6x to the power of 4 plus 10x to the power of 3 plus 3x to the power of 2 equals 0. The degree of the polynomial is 5. Thus, as said earlier, the number of roots of the equation is 5. This knowledge helps us identify how many possible roots are needed to be eliminated and whether the fundamental theorem of algebra must be applied. Let's start off with an easy round. Find the possible roots of the polynomial equation negative x squared minus 7x cubed minus 12x squared plus 4x plus 16 equals 0. Did you get the right answer? If you didn't, then just keep watching. But if you did, then just go on to the average round. According to the RRT, we must find the factors of the constant term and divide that by the factors of the leading coefficient. First, let's find the factors of 16. Because the equation consists of a negative sign, we must make use of positive negative factors. Ergo, the factors of 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. Next, we must look for the factors of negative x or negative 1, which is simply plus or minus 1. With these, we follow L over F. So the final answers are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. You can box your answers, and there it is. Since the problem just asked for the possible roots and not the root itself, it is safe to stop here. It is now time for the average round. How many possible negative roots are there in the polynomial equation x cubed minus 3x squared minus 13x plus 15 equals 0? Did you get the right answer? If you did, you can move on to the difficult round, but if you didn't, keep on watching. Before we start solving, let us remember that we are only looking for the possible roots. We are not trying to find the zeros of the set polynomial. So first, identify the constant term and the leading coefficient of the given polynomial. Next, look for the factors of the constant term 15, which is the LNR formula, which will give us plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Look for the factors of our leading coefficient, which is 1, and it is the F in our formula, which will give us plus or minus 1. Next, plug in the values of the formula L over F, and the roots are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So this means that There are 4 possible negative roots. It is now time for the difficult round. Use rational root theorem to solve this polynomial equation 3x cubed plus 23x squared plus 50x plus 24 equals 0. Did you get the right answer? If you didn't, keep on watching, but good job if you did. First, we look for the last terms by looking for the factors of positive 24, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, and plus or minus 24. The first terms are plus or minus 1 and plus or minus 3. You can get that by factoring positive 3. Now, L over F will be plus or minus 1, plus or minus 1 over 3, plus or minus 2, plus or minus 2 over 3, plus or minus 3, plus or minus 4, plus or minus 4 over 3, plus or minus 6, plus or minus 8, and plus or minus 24. Using the remainder theorem, you can solve using synthetic division with negative 3 as a divisor, and 3, 23, 50, and 24 as a dividend. Apply synthetic division and numbers below will be negative 9, negative 42, and negative 24. Now, add all the numbers and you will get 3, 14, and 8. Let us now use factoring with those numbers, 3x cubed plus 14 plus 8. 8 times c equals 24, and split in half it will be 2 and 12. Factor that out will be, from one parenthesis, 3x cubed plus 12x, and another parenthesis, 2x plus 8x. Factor again to be 3x and one parenthesis, x plus 4, plus 2 and another parenthesis, x plus 4. Using zero product property, transpose 3 and x plus 3, and you will get x equals negative 3. Transpose again 2 and 3x plus 2, that's in one parenthesis, and you will get x equals 2 over 3. Transpose 4 and x plus 4 in one parenthesis, and you will get x negative 4. Now we have the roots, x equals negative 4, negative 3, and negative 2 over 3. In summary, the rational root theorem is a theorem which describes the relationship between the roots of a polynomial and its coefficients by finding the factors of a constant term and leading coefficient and plugging it into the L over F. It isn't always guaranteed that we get the roots right away, but we are only given the possible roots. It is our duty to check the possible roots to find the zeros of the polynomial.